Alright, this is lesson 5.6, right, our last lesson of our inequalities unit. And what we are doing today, or what this lesson is we are going to graph our inequalities. Alright, so the lessons leading up to this, we've solved inequalities. So now we're going to solve and then graph. Right, so there's no vocab, theorems, properties that we need to know, so we're just going to get right into our examples. Right, so our first example, we're going to have 3x minus y is less than 2. Right, so the first thing we need to do is solve. We want to solve for y, because when we solve for y, that gets it into that slope-intercept, just like we have with equations, right? If we solve for y, right, we have this x, that's going to give us our slope, and then we're also going to be given a y-intercept to make it easy for us to graph. So first thing I need to do is subtract 3x, get negative y is less than negative 3x plus 2. Alright, and then we multiply everything by that negative 1 to get rid of that negative. So we're left with y. We flip the sign since we're multiplying by a negative. 3x minus 2. Alright, so y is greater than 3x minus 2 is my inequality. So now I want to go ahead and graph that. Graphing is my second step. Right, just like with slope-intercept form, right, this is going to be our y-intercept, so negative 2. Right, and then we have a slope of 3, so we go 1, 2, 3 over 1, right, gives us those 2 points. Right, before we put in a line, we don't want to draw a line because they're different. Right? I guess we can go ahead and put these up in vocab and theorems. Right? We're going to have a different line for these and these. Right? There's two different lines. Right? Whenever we have just a less than or greater than, right, we're going to have a dotted line. Whenever we have a greater than or equal to or less than or equal to, that's when we have a straight line. Right, so for this one, since we have greater than, just greater than, we're going to have a dotted line. Right, because that means anything on that line won't work. Right, it has to be, greater than to make it work. Right, and then our second step is to shade. Right, so shading can be a little tricky, right, depending on where our line is, right, but this says y is greater than 3x minus 2, which means we want to shade above our line. Right, now with this line, if we look, right, this line right here, this would be above, this would be below. Right, so we're going to shade here. Right, with some of them, it might be a little hard to determine what's, above or below, right? But that's why we check. Right, so far this is our answer, but we want to check and make sure we're right. Right, so to check, we want to pick a point in our shaded area to see if it works. Right, so for example, we can pick the point 0, 0, right, an easy point to check, and we want to see if it's true. Right, so we can plug it into the original or the one that we came up with. I'll just plug it into the original to show you that it'll work all the same. So if we have this and this, what we're left with is 0 is less than 2. Which is a true statement, which means we shaded correctly. Alright, let's try another one. This one, x plus 4y is greater than or equal to 2. Right, again, first thing we want to do is solve for y. So we subtract x from both sides. We're left with 4y is greater than or equal to negative x plus 2. And then we divide by 4. So we're left with y is greater than or equal to negative 1/4 x plus 1/2. Alright, we want to go ahead and graph. Alright, so our y-intercept is at 1/2, which is going to be, right there in between 0 and 1. And then our slope is a negative 1/4, which means we want to go up 1 and to the left 4. 1, 2, 3, 4. Alright, so it'll be around there. Again, with fractions or decimals, estimate. Right, so that's that. Then we have to figure out if we have a dotted or a solid line. Since we have a greater than or equal to, our line is going to be solid. And then since it is greater than, it wants to be above the line. So we're going to shade above the line. Which means anything on the line or above is true. Right, again, we're going to check just to make sure. So if we look, you can use any point within the shaded region. I'm going to use 0, 1. Alright, which would be like that point right there. Alright, just to make sure it's true. Right, so we get 0 plus 4 times 1 is less than or equal to 2, which is just 4 is greater than or equal to 2, which is true. Right, so we know we have shaded correctly. Alright, go ahead and flip. Alright, one more and then we'll do one more type of example that will come up. Alright, so first thing we want to do is, in this one, notice that there's no y. Alright, so since there's no y and there's only one variable, we want to just solve for that one variable. So we're just going to solve for x. Right, so that's why I'm subtracting 3. We get 2x is less than or equal to 4. And then we go ahead and divide by 2 to give us x is less than or equal to 2. Right, just because we don't have a y doesn't mean we can't graph it. Right, whenever we have x is, whatever inequality or y is whatever, they're just going to be straight lines, either horizontal or vertical. Remember, with equations, if we have x equals something, that is a vertical line. So whenever we have the inequality with just that x, it's also going to be a vertical line. Right, so since x is less than or equal to 2, we know we're going to have a line at 2. Since it's that less than or equal, we have a straight or a solid line. Right, and then since we have x is less than, we want all values that are less than 2, right? So we would shade over this way. Alright, to check, pick any point, pick the point 0, 0, that falls right in the middle there. Right, so we get 2 times 0 plus 3 is less than or equal to 7, which gives us 3 is less than or equal to 7, which is true. So we have shaded correctly. Alright, one more type of example that I quickly want to hit. It's not going to show up in your homework, but it will show up on your test, is to write the inequality from the graph given to you. Right, so we're just going to go ahead and look at B. Right, so what we want to do is we want to write an equation in our slope-intercept form, right, of this line or this inequality right here. Right, so first thing we want to do, right, we really just want to find, slope and y-intercept, put it into our inequality, and then we'll worry about the sign. Right, so we need to find slope, and we need to find our y-intercept. So y-intercept is easy, that's just 2, right, and then our slope, we go up to over 2, would be a -1. Right, so what that's going to give us is y, whatever inequality we have, -x plus 2. Right, so now we need to figure out what inequality we're going to put there. Since it's a dotted line, we know it's either going to be greater than or less than. We just have to figure out what one. Right, so if we look, our shaded region is on top. Right, if it's on top, that's going to mean we want to use our greater than symbol. Right, so that right there would be our answer. Right, for these you can also double check. Right, once you write your equation, you can pick a point and make sure it's true. Right, if it's not true, then you know you've written the wrong sign. Right, for example, we can pick the point 1, 2. Right, to do a little check here. Right, and I'm going to plug it into here. So we have 2 is greater than -1 plus 2, which would simplify to 2 is greater than 1, which is true. Right, so we know we have assigned the correct inequality symbol. Right, that is it for lesson 6.